Hey, welcome. The subject of this class today is inheritance in Java, and we're going to explore both a parent and a child class, also known as a super or subclass. You can see that right here. So if you were in on today's Zoom session, you'll see a lot of the same, and so this is really for people who missed it. Why, I don't know. Okay. Well, why do we use inheritance? And I think the key word here is reusability. We've run across examples of inheritance already. All the classes we made in Greenfoot extended the actor class, and that allowed us to reuse various of the methods and fields that existed in that class, the actor. For example, get X, get Y, move, any of the methods in the actor class we found actually quite handy when it came down to programming our own child or subclass, such as Greep or Asteroid. And so here's an example where you have a class employee and a programmer extends an employee. So the base salary for an employee, as you can read this, is 4,000, and the bonus for a programmer is 10,000. So we create a new programmer, we output the programmer salary, we can output the programmer bonus, and that is all that we need. And so, how do we get that salary? It's stored up in the employee class, p.salary. So let's look at the example we worked over today in CodeBoard. Okay, we started with the parent class, and you can kind of see that right here. Oops, close that and minimize that. Public class parent. So our parent class has a name. It also has a constructor, takes in a name, argument, or parameter and sets that value into the instance variable named name. So this refers to the instance variable and name refers to the parameter value. And it also reports out its name. It returns a string, which happens to be name, which is the instance variable, which was set to the value of the parameter. Now, our example also had a child class, and the most critical part, if you were in today's session, is that it extends the parent. We will note that Java only has single inheritance. There can't be, as biologically true, more than one parent. Other languages do. But we also have something that's different than the parent. The child also has a model number. So while the product may be, TV as opposed to toaster as the name, the model number would be unique for every instance of child. The first thing we do in our child class constructor is call the parent class constructor using the keyword super, which in another way of describing the parent-child relationship would refer to the superclass, and the child would be the not superclass. I have to look it up. Name escapes me. But we pass the name parameter here and its value over to the parent class constructor that we just went over. We take modnum and store it into the instance variable modnum. We create a little accessor because it's good to create an accessor, usually starting with the word get, for every instance variable that we have. And note the toString, which we want to put not only because the unspoken parent of parent, the daddy of parent, the daddy of all in the inheritance hierarchy is the capital O object class. So we want to override the capital O object class toString method. And look what we do. We call the super class method getName, and we report out the model number. So a little test of main says we're going to create a child called Cal, and we can output Cal, and that would call the toString method. So let's compile that, and I will drop the beat. The compilation's successful, and I run it, and it outputs Airplane 4500 because it's calling the toString method in the child class. I'll add it a little bit more than what was in there. I can call it parent P equal new parent, and I can give it a name, but I can't give it a model number because the child class is the one that records the model number, and I can go right here and type in something like that, and I'll go with P, and we'll see what happens. And what we're going to get is a little bit surprising. What don't we get here? We're calling the object class toString method, and that's why the memory address is reported. And so I'm going to go in and create a public string toString method, which will basically return name. And now when I compile main and run it, because I put the toString method in, it reports out the word truck. A little variation of what you can do. You can go parent A equal new child auto, comma 38500. Does that compile? Can I put a child into a parent? Yeah, looks like I can, but watch what happens. Nothing, because the compiler knows that even though it's in a parent body, what's inside is a child, and it obviously calls the appropriate toString method. That's called upcasting. I'm going to take it back and say it's called downcasting. It's one of the two, but it's definitely downcasting. where you take A and make it into a child. Well, this is where I'm going to stop today. I'll share this video for people who missed the Zoom session. Your project is to create some parent-child class that makes sense. Remember that the parent class will have the attributes and actions, properties, instance information, and methods that pertain to every child. And the child class will contain information such as model num that pertain only to it. So in a sense, in a very real sense, it adds on to the functionality of the parent class for a unique purpose or to suit the programmer's need. Well, this has been great. Appreciate it. Max out.